Let's consider function f of x equal x squared minus 4 over x plus 2. The domain of that function is the set of all values of x that are different than negative 2. We are to find the asymptotes of that function. Well, let's start with the vertical asymptote. As always, we'll write the function in the lowest terms. So we factor both numerator and the denominator, and here only numerator factors as x minus 2x plus 2, and the denominator is already factored at x plus 2. You can see that they both numerator and the denominator have a common factor, therefore we can reduce that fraction, and as a result we'll have just x minus 2. And this is going to be true only when x is different than negative 2, when x plus 2 is not 0. So the function f of x is really given by the formula x minus 2 when x is different than negative 2. It is not defined when x is equal negative 2. F of negative 2 is not defined. So if I want to graph this function, I know how the graph of this function looks like. The graph of this function is the graph of the straight line y equal x minus 2. This is the function with, this is straight line with y-intercept negative 2, the slope 1, so it goes through the point 1 and negative 1. And therefore the graph of that function is going to be straight line everywhere except x equal negative 2. The value of the function at negative 2 does not exist, so we cannot have point on a graph that has x coordinate negative 2. So this point, when x is equal negative 2, has to be punched out. We have to make a hole in this graph. So we have a graph of the function with the hole. This happens when the function, when the rational function has common factors. It is not in lowest terms. This can result in a situation like here that there is a point that does not belong to the graph. Now our objective was to find the asymptotes. Now since I graph the function, that I can see that there is no vertical asymptote. The graph has no vertical asymptote. However, if you look at the original formula, you can say, well, the degree of numerator is 2, the degree of the denominator is 1, so there should be oblique asymptote. And where is that oblique asymptote on the picture? So let's recall what oblique asymptote is. An oblique asymptote is a straight line such that the graph of the function approaches it when x increases or decreases without bound. So in this case, we can say that the line itself is an oblique asymptote, and therefore its equation is going to be y equals x minus 2.